Welcome to Understand the Math. In this video, we're going to learn about Gaussian elimination, a systematic method for solving systems of linear equations. We'll begin with an overview of how Gaussian elimination works, and then go over a few key concepts that you'll need to know: an augmented matrix, elementary row operations, and row echelon form. And finally, we'll walk through two examples step by step to understand how the method works in practice. Let's begin with a quick overview of how Gaussian elimination works. Gaussian elimination is an algorithm used to solve systems of linear equations. Here's a system that we're going to solve with two equations and two unknowns, and then one with three equations and three unknowns. When you perform Gaussian elimination, you start with a system of linear equations like these two listed here. You then put the system into an augmented matrix. I'll tell you exactly what that is in a minute. Then you're going to use elementary row operations to put the augmented matrix into a matrix in row echelon form. We'll talk about both of those concepts also. Then the last step is you use what's called back-substitution to solve for the variables. We're first going to learn how to put a system of equations into an augmented matrix. An augmented matrix is just a way to represent a system of linear equations using only numbers in a rectangular array. With an augmented matrix, the coefficients of the variables are on the left-hand side, and then the constants are on the right-hand side. Let's look at an example so you can see exactly how this works. We're going to take this system. It has two equations and two unknowns, and we're going to put it into an augmented matrix. All we're going to do is put the coefficients that multiply our variables on the left-hand side. So that's going to be a 1 and then a 2. And then in the second equation, we have a 2 and a 3. And then it helps to draw a line. That just gives you a visual reminder of the equal sign. And then on the right-hand side, you just have your constants, which in this system are 5 and 8. The matrix just has constants in it and no variables. Let's now learn about elementary row operations and row echelon form. We need both of these when we do Gaussian elimination. Elementary row operations are just algebraic operations that are used to put an augmented matrix into row echelon form. And once it's in row echelon form, the solution to the system can easily be found. Let me show you exactly what this looks like. Here's the linear system that we talked about on the last page. We took that linear system and we put it into an augmented matrix. We're then going to take our augmented matrix and put it in what we call row echelon form. We'll go over that in a minute. Once you have a matrix in row echelon form, you then put it back in terms of algebraic equations, and then we're going to use what's called back substitution to find the solution. I always think it helps to have an overview of that process before we actually work through it. Elementary row operations are the operations that we're going to use on the augmented matrix to put it into row echelon form. There are three operations we can use. The first one is we can interchange two equations. The second one is we can multiply one of the equations by a non-zero constant. And then the third one, which is the one that you use most of the time, is you're going to add a multiple of one equation to another equation. These three elementary row operations are what we use to put our matrix in row echelon form. If we have a 2 by 2 matrix, row echelon form can look like this, and you're going to have a 1 on what we call the diagonal, and then to the right of the ones and above the ones, you can have a number. It can be any number, including 0. And this is what it can look like if you have three equations and three unknowns. The ones are on the diagonal, and then you have numbers above and to the right of those diagonal entries. I want to make a note that the diagonal entries do not need to equal 1, but it does make it easier. In pink, you can see what it looks like when they're not equal to 1. Let's now walk through an example step by step so you can understand how this method works. We're going to start by taking our system of equations and put it in an augmented matrix. We already went over how to do this, so you know exactly what to do. We have a 1, a 2, we draw our line and we have a 5, and then we have a 2, 3, and 8. Now what we're going to do is use elementary row operations to put this into a matrix in echelon form. Before we begin, I'm going to label our rows. Our top row is called row 1, and then our second row is called row 2. We want to get a 0 in this entry right here. So what we're going to do is we're going to use the row above it, and we're going to use this entry to make the 2 highlighted in yellow equal to a 0. That's called a row operation. So what we're going to do is we're going to take row 2 and we're going to replace it with row 2 minus 2 times row 1. Let's see what this looks like. Our top row is going to stay the same, so let's go ahead and let's copy that down. Now we're going to take that top row, multiply every entry by minus 2, and add it to our second row. So we're going to get a 0. In this entry right here, we're going to have 2, and we're going to multiply it by negative 2, and then we're going to add the entry that was there, which is 3. So that's a minus 4 plus 3 gives us a minus 1. Now let's talk about this entry right here. We're going to take 5, multiply it by minus 2, and then add 8. So that is minus 10 plus 8, which gives us a minus 2. Now let's look at this entry. It would be nice if that entry were a 1. So what we're going to do is we're going to use the row operation where we can multiply a row by a number. And I'm going to take row 2 and I'm going to multiply it by minus 1. So row 2 is going to go to minus 1 times row 2. Row 1 stays the same, 1, 2, 5. And now in row 2, everything gets multiplied by a negative 1. So we have a 0, a 1, and a 2. Now our matrix is in row echelon form. We have a 1 along the diagonal, and then we have numbers above and to the right of the diagonal entries. Now what we're going to do is we're going to take that augmented matrix and we're going to put it back in terms of equations. On our top row, we have a 1, so that becomes x, and then we have a 2, so that becomes 2y, and we have a right-hand side, which is 5. And then in the second row, we have a 0, so we won't write down anything for that. And then we have a 1, that multiplies y, and our right-hand side is 2. We now know that y is equal to 2, and we can substitute that back up into our previous equation. This equation then becomes x plus 2. Now we're going to plug in y is 2, and we get 5. So this is x is equal to 5 minus 4, which gives us x is equal to 1. And that gives us a solution equal to 1, 2. Or you can just say x is 1, y is 2. Now what we're going to do is we're going to go on and we're going to do the same thing, but we're going to have a system of 3 equations and 3 unknowns. Let's now walk through our second example. This is our example with 3 equations and 3 unknowns, and we're going to start just like we did with our previous example. We're going to take these equations and we're going to put them into an augmented matrix. We're just going to write down the constants. So this is a 1, a minus 1, and a 3, a 1, a minus 2, minus 7, and then 2, 3, and 4. And then on the right-hand side, we have 8, 1, and 10. I always tell my students, once you complete this step, what you need to do is glance back up and just check your work, because it's really easy to make a mistake right here at the beginning and just not copy down the constants right. Now what we're going to do is we're going to start using row operations to write this matrix in row echelon form. We want to get these two entries to be equal to 0, and we're going to use this entry to do that. Let's just remember that this is row 1, this is row 2, and then this is row 3. I'm first going to get the -1 that's highlighted in yellow equal to a 0. So I'm going to use row 1 to do that. So I'm going to say row 2 is going to go to row 2 plus row 1, because if we add 1 and -1, we're going to get 0. One of the great things about Gaussian elimination is that you can do a couple of steps at once. So we're also going to get rid of the 3 at the same time. So now we're going to say row 3 is going to go to row 3 minus 3 row 1. Because if we multiply that blue 1 by a -3 and add it to the 3 in the bottom row, we're going to get a 0. Now let's go ahead and find out what all these entries are. Our top row is going to stay the same, so let's go ahead and let's write that down. Now we're going to take row 2 and add row 1 to it. So this gives us a 0, a -1, a 5, and a 9. Now we're going to take row 3 and replace it with row 3 minus 3 times row 1. So this is going to be a 0. Now we're going to take this 1, multiply it by -3, so that gives us a -3. We're going to add it to the -7, and we get -10. Now we're going to take the 2, multiply it by -3, that gives us a -6. We're going to add 4 to it, and we get -2. Now we take our 8, multiply it by -3, so that gives us a -24. We're going to add 10, and we end up with a -14. Now let's look at this entry. That entry has a -1, which would be okay. We can leave it like that, but in my experience, I think it's easier if we multiply that row by a negative and make it a +1. And then notice while we're doing that every number in the bottom row is also negative. So let's just go ahead and let's multiply both of those rows by a -1. We're going to notate that and say that row 2 is going to go to -1 times row 2, and then likewise row 3 is going to go to -1 times row 3. You might also notice that in row 3, every number is a multiple of 2. So we really could have divided by 2. I'm going to choose not to do that, but if you want to do that, that's completely fine. Now let's see what this gives us. Our first row is going to stay the same, 1, 1, 2, 8. Now we're going to take our second row, multiply it by a -1. So this becomes a 0, 1, -5, -9. And then every number in our third row also gets multiplied by -1. So we have 0, 10, 2, 14. What we need to do now is we need to get this number equal to 0. So we're going to use the 1 above it to make that happen. The row operation that we're going to do is we're going to take row 3 and we're going to replace it with row 3 minus 10 times row 2. Let's see what this gives us. Our first two rows are going to be the same, 1, 1, 2, 8, and then 0, 1, -5, -9. On our third row, we have a 0, and then we're going to have our blue 1 times -10, add it to our yellow 10, and we're going to get 0. Now let's go back and look back to the upper right. We're going to now take -5, multiply it by -10, which is going to be 50, and then we're going to add 2, so we get 52. Now we're going to take -9, multiply it by -10, that is 90, and we're going to add 14, so we get 104. This matrix is now in row echelon form. Our entries along the diagonal are either 1 or other numbers. We could have easily divided row 3 by 52 to make that number of 1, but we don't have to. And then we have numbers to the right of those yellow entries. Now we're ready for our back substitution. What we're going to do is we're going to take our matrix and we're going to put it back into algebraic form. Looking at our first row, this gives us x plus y plus 2z is equal to 8. Our second row tells us that y minus 5z is equal to minus 9. And then our third row tells us that 52z is equal to 104. We're going to take our third equation and we're going to solve it for z. So we're going to divide each side by 52 and we get z is equal to 2. Let's highlight this. Now we're going to take that value for z and we're going to plug it back up into our second equation. So our second equation becomes y minus 5 times z, which is 2, is equal to minus 9. This gives us y is equal to minus 9 plus 10, which is 1. Now we're going to take this value for y, plug it back up into our first equation, and plug z also back up into our first equation. So this becomes x plus y, which is 1, plus 2 times z, which is 2, is equal to 8. Let's go ahead and let's see what this is. This is 1 plus 4, so this is 5. So we have x is equal to 8 minus 5, which is 3. We can then write our solution. So our solution is equal to 3, 1, 2. And that's it. You now know how to do Gaussian elimination. You put your system of equations into an augmented matrix. You use elementary row operations to change that matrix into a matrix in row echelon form, and then you use back substitution to solve for your variables. With a little practice, you'll get really good at doing this.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.